It's my great pleasure to introduce Dick Frenkiel. He really is one of the few people who can stake claim to being a creator of Cellular. And he's won just about every award that you can. I won't go through the entire list, but the Alexander Graham Bell Medal, the National Academy of Engineering member, the Draper Prize, National Medal of Technology, which is given to you by the President, which he won in 1994. All of these for his contributions to cellular systems, and more importantly, I think, of making them a reality, a practical reality. And personally, I had the benefit of working with Dick. He hired me in 1982 at Bell Labs, and he was my department head, and it was a wonderful place to work. I realized right away it was kind of an intense job they had. They were getting the first cellular system up and running, and so it was intense, a lot of work, but Dick made it fun, and it was always fun. And so I really appreciate that he's come and give us a talk. I thought I'd mention one more thing, which he never mentions in his bio. I believe he was the mayor of his town, of Manalapan, which is in Monmouth County. Is that true? It is true. So I just thought I'd throw that one in. And he wasn't indicted. So let's please welcome Dick Frenkiel.
Good afternoon. Can you all hear me? Yes? Good. I struggled with this a bit after I accepted the invitation. In the first place, I wondered what the title of the talk meant. I was not sure whether it implied that I was a distinguished speaker or whether I was going to give a distinguished speech. And then that's not the same thing. I needed to figure that out. So I asked my wife if she thought I was distinguished. That did not lead to a good place. So I decided, well, it must be a distinguished speech I'm giving. Am I echoing? Okay. It's a little bit less? Or? So I'm not sure what a distinguished speech is. But I figured out finally that distinguished has two meanings. You could mean that you could distinguish my talk from any other you've ever heard. And that I can live with. So, I decided, first of all, that the target for this talk is the students here. Because all the faculty know more than I do. So, I wanted, seriously now, to find a way to talk about things like cellular systems, but in a way that leaves you with something. And so that's my goal, and we'll see how it works out. I will say that part of my message is, and the faculty should not listen to this, is that the faculty's been misleading you about some things. Well, the way I would prove this to you is you've had exams, right, throughout your entire career. And the exams control your grades, the grades control your future in some way. So what I would contend is true is that every single question you've ever answered on an exam had a right answer. Is that true? I mean, a calculable, a provable right answer. And that's a very misleading thing, because in general, life is not like that. And so I give you an example. So you've answered all those provably correct things for a bunch of years, and let's say you have a 3805 cum, and so you get a bunch of job offers. And let's say one of them has the biggest salary, and another one is with a great company. and a third one is near where your significant other is going to be working. And another one is near the ski slopes. You see, the point I'm getting to is, what's the right answer? What's the right answer for where you should work? And obviously, there is none. That it's going to come down to a decision which is, at least at the time you make it, unanswerable. And in fact, you never will know if it was the right answer. It may turn out well, but hell, a different one might have turned out better. So it's the kind of question that doesn't have an answer. And I would suggest that that's not an impediment. You've been answering questions like that all your life, right? I mean, you know things, you make decisions. You decide which road to take to work in the morning. You know, one of them's prettier, the other one has a gas station, and you're halfway out of gas. You make decisions like that. And yet, I suspect that when it comes to what you've learned and the career you will implement that in, you have more of a sense that that stuff is different. That stuff is sort of pure, and it does have right answers because you've been trained to find those answers. So what I want to suggest to you today is that, sure, that's true. There is a piece of doing the kind of work we do that does have that aspect that you work hard to find a right answer. But I would also suggest to you, my own experience is, that the work we do is done in a messy world where a lot of other things are important and can be ignored at your peril. So my goal today is to present the work we do in that sense of that it's both kinds of things. And I think that the cellular history is a good example of that. The very fact that I called it a history, a drama, those are non-technical terms. And believe me, it was that way to work on it. So I want to use cellular as a route, but you know, you don't really care that much about the first cellular system. The technology is ancient, it was simple. But seeing the way that played out, I think, could be meaningful. So that's what I decided would be my talk. And by the way, since this is a quick talk, there's a lot of stuff that's interesting about cellular, I think, that isn't in the talk. I wrote a book which was, the actually original intent was that I thought Bell Labs was a fascinating place, and it doesn't exist anymore. I mean, I guess it exists, but not the Bell Labs that I was part of. And I wanted to capture that, what it was like to be there. But I also wanted to talk about cellular and so on. So there's stuff in there. If you like that stuff, you can read it. It's a download. You don't have to copy it. If you Google cellular dreams, it'll come up. And it's free. And it's worth every penny. So, we'll start with a quick look at what I mean by the acts. We're talking now about a 70-year history of cellular. Isn't that's, by the way, that's kind of discouraging because I remember 50 of them. It would be difficult and I think boring to talk about just a chronology of 70 years and what happened every year. But fortunately, it breaks down into 4 recognizably different periods of time. The Act 1 period was the idea of cellular and why it didn't happen. Act 2 was the creation of cellular. Act 3 was that explosive growth of cellular that took place for the first 20 years. And Act 4 is your smartphones. So each of these periods of time had different rules, different things that turned out to be important. But in general, what I want you to see is the interplay between the technology that you take joy in creating and politics and economics and competition. You don't necessarily love those things, but they will impact your life if you're trying to create something new. And the important thing is to be aware of that possibility so that you will notice which one of them might be actually important this time. And in each of these phases, different things became important. So let's begin. Use this. So the idea. In about 1946, the government gave AT&T roughly 5 channels and said, here you can have a mobile radio telephone system. 1 year later, that was the map of coverage in the United States. The filled-in circles are systems that are working, and the ones that aren't filled in are going to be working pretty soon. You're talking about a year after they got the channels, they had well over 100 systems working. And that sounds pretty impressive. But you know what the system was? It was a radio. You got a radio and you stuck it up on a hill somewhere, you attached it to an antenna, you put that on a mast, and you were done. Oh, and one more thing you needed was a wire leading to an operator, so that when you clicked on your handset, the operator would say, mobile, and you'd tell them what channel you wanted. That's how crude this thing was. It's one high-powered channel in the middle of a city. And what I show there on the right, that's New York. Now, New York was a special system in one sense. They put the antenna up on the Empire State Building. So that had a pretty big coverage area, probably over 30 miles. Other places would have maybe a 20, 25-mile coverage. That was a system. When you got to the edges of the system, your service got bad. When you left the system, there might be nothing. You might cruise into a different system there, but more likely you just left the system and there was no service. And just to make a guess, there were 10,000 customers in the US. And at any given time, 100 calls. And even 20 years later, still before cellular, if you looked at the entire eastern seaboard of the United States, you might have 200 people on the phone in their cars. 200. You have vastly more than that on this campus now. So that was the system then. And a Bell Labs engineer named Doug Ring, he looked at that map, and instead of seeing many, many coverage areas, he looked at all these places that weren't covered. So his thought was people should be able to continuously move and always have coverage. So how did you do that? He envisioned a grid of coverage areas, not focused on being in the center of a city, but just putting one after another in a nice, precise pattern so that the coverage areas interlocked and you were always in a coverage area. So he was not interested in high capacity. That happened later. So when he drew a cell grid, like the one on the right there, he was simply talking about continuity of coverage. But he did notice that within that grid, after a certain distance, you could use channels over again. So that what you see there, that big hexagon, channel 1 or channel group 1 could be used in a bunch of different cells. But those cells were not near each other. I show those 2 red circles. That's New York. And so maybe 2 times in the New York system you could use a channel, but not many times. So that was the step, though. That was the first time somebody drew a cell grid. So you might think, why were channels so scarce? Why weren't there hundreds of channels? And the reason was simply that the upper frequency that was useful was not what it is today. Today, you could buy consumer products, cheap radios that work up to 10 gigahertz. Obviously, soon it'll be higher than that. At this time, though, they only had about 500 megahertz of channel space that was considered useful. But then, within that space, who would get it? Well, TV was a new popular service. The police needed them, fire needed them, companies needed them to control a fleet. So where did mobile telephones stand in all this? Unimportant. So when there were channels, they were lucky to get those 5 channels in 1946. Then in the 1950s, what was considered the acceptable practical limit, when it doubled, it went to 1 gigahertz. And so suddenly, there's 500 megahertz of new spectrum, doubling basically the allocatable channels. And the FCC had hearings. What should we use them for? And AT&T got in there and said, mobile telephone would be good. Well, those were the days of popularity of TV. And so all of that spectrum, all of it, went to create, 70 more TV channels, the UHF band. And the dream that the FCC presented was a new era of cultural and educational TV. It didn't work out that way. And in 1962, the FCC chairman, one Newton Minow, gave a famous speech, which it's still remembered as the Vast Wasteland speech. If you Google Vast Wasteland, you'll come up with this. And I quoted this because it's so cute. He said, TV programming was a vast wasteland of game shows, formula comedies about totally unbelievable families, blood and thunder, mayhem, violence, sadism, murder, Western bad men, Western good men, gangsters, more violence, cartoons, and endless commercials. And he suggested that they clean up their act. And they didn't, because, TV likes sex, violence, and commercials. So what happened was, and this is privately within the FCC, they started thinking about maybe taking back some of those channels. At the same time, at Bell Labs, a mechanical engineer was hired, as I say, of limited promise, who did boring mechanically things and got in trouble. But suddenly, in the way of the large corporation, there was a reorg. And my new department head called me in, and he said, I have a choice for you, Dick. You could work on a new radio system, or we could send you to Indianapolis. And there you could work on the stuff you have been working on. I knew absolutely nothing about radio. I wondered at the moment, does he know I'm a mechanical engineer? Did he mistake me for someone else? I had no idea, but I knew I didn't want to go to Indianapolis. So I said, sure, I can do that. Now, this would have been a disaster, except that I got to work with a Bell Labs engineer, Phil Porter. I describe him as, he had a doctorate in physics and ECE and 10, 12 years experience in radio. And he was a prince among men. He taught me everything. In the next 6 months, our job was to describe what is now thought of as a cellular system, only in a different way than that other one I showed you. The question was, with small cells, where you could repeat each channel many times in a local area, how many people could you serve? And how far apart would the channels have to be? And how would you control the system? And a bunch of questions that talked about the viability of a cellular system. And this was a joy. I mean, the work we did was to come in every morning and talk about stuff. Could we do this? Could we do that? How would we figure this out? And all the time now I'm learning. And I remember, I think I did have good ideas, but I also had really stupid ideas, which is the nature of the thing when you're working in a technology that you don't understand. And he never made me feel stupid. If I offered a stupid idea, he would say, oh, let's talk about that. And we'd talk about it a while, and then I'd realize it was stupid. And I'd stop talking about it. But the reason I'm mentioning this is because Phil Porter, what did I just do? Okay. Phil Porter made my whole career by being a gentleman who was willing to take the time to help me learn stuff. He gave me what became the whole rest of my career. And that's called mentoring these days, I think. And I mention it because you can really make a difference in someone's life. So now Ring's coverage idea of his ring cells were 5-mile radius to 15-mile radius. Ours was 1-mile radius. So the idea was the smaller the cells, the more the capacity. And we had to figure out all these things about the system. And by the way, in the time of Ring, in 1947, there were not only no channels, there were no computers. This kind of a system needs control. So really, Ring's proposal was sort of a blue sky thing that had no possibility of being realized. But in the 1960s, we worked on this in 1966, there were the first electronic switching systems in the Bell system, ESS, the number 1 ESS, which was a programmable switch. And with a programmable switch of great power, you could do all kinds of new things, like control a radio system. So these things were now possible. So what happened? We worked on this for 6 months. We wrote a memo. Nobody cared. We filed it. We went on to work on other things. But then, 2 years later, in 1968, the FCC did act. And they offered to reallocate 14 TV channels to mobile radio kinds of things, including telephony. So now, suddenly, some big things become possible. And at that moment, only 2 people in Bell Labs knew what a cellular system was. One was 24-year-old kid, and the other was Phil Porter. So we became popular people. I got to give a talk to the second in command of Bell Labs. I never would have been allowed to do that. And that was cute, by the way. To do the talk to the executive vice president, Julius Molnar. They wouldn't trust a kid to do that. So I had to rehearse this talk with my supervisor, who made corrections, and then my department head, and then my director, and then my executive director, and then my vice president, and then Julius Molnar. Which means that by the time I gave the talk, I was bored with myself. And that man listened to my whole talk with his eyes closed. Well, the condition that the FCC made was that industry should create more spectrum-efficient systems. And so we had that system. And I always wondered, the department head that called me in the very beginning, why did he have us working on that system 2 years before? That couldn't have been a coincidence. He must have known someone in the FCC and thought they were about to act then and wanted to be first in line with the system. But he died just when the FCC acted. Life is strange. So, what we promised the FCC is we would give them a better proposal soon. And now Phil and I are becoming part of a bigger group, and we're filling in details. Our memo of 30 pages long or 40 pages long became a book, which we sent to the FCC at the end of 1971. So AT&T, with that book, that system description, sent a letter to the FCC making a couple of commitments. To show its commitment to service, they said, we're starting development right now. We're not even waiting to see what happens. Of course, what they're trying to do is twist the FCC's arm to say, we're spending a lot of money, you better do something. But the other thing they agreed to do had to do with the monopoly. And I should say, since many of you were not alive then, in those days, the AT&T was the Bell system, the monopoly that had all the telephone companies, long distance, manufacturing, Bell Labs. This is all part of the same company. And for half a century, the Department of Justice had been trying to break up the AT&T monopoly. And manufacturers didn't like the AT&T monopoly because we didn't buy from them. We designed it at Bell Labs. Western Electric built it. And that really bothered other people. So the industry that manufactured radios was not going to be happy about us having this big new service. So they were against AT&T. AT&T therefore committed not to manufacture cell phones. And when they did that, a lot of the manufacturers then said, fine, then we're happy. Motorola never did. Motorola was the biggest radio manufacturer in the world, and they could see already that this structural change of a cellular system would change the world for them. It would become, instead of a high-margin specialty business that they had selling systems to individuals, there'd be one big system out there and they'd be just selling cell phones in competition with everyone else. So they were really against AT&T. So we're starting development in 1971, but the beginnings of opposition to us as a monopoly have already begun. And that conflict between the power of the monopoly to provide a good service and the resistance to the monopoly as a matter of policy was the central environment of the entire development process. And it made things take years longer than they would have. In particular, when you're working with the FCC, their very process makes delay easy for others to cause. For example, they put out their first proposal about those TV channels becoming, by the way, I didn't say, I think, those 14 TV channels are about 2,000 mobile radio channels. So you're talking about a lot of channels. Ultimately, half of them went to cellular, so that's where cellular came from. 7 of those 14 channels is cellular, plus many more since then. But in those days, those first 1,000 channels created cellular. So we had this slow-moving process. The FCC put out this proposal. We might give you 14 channels worth of spectrum, and asked for comments in 6 months. 6 months later, hundreds of companies comment. And then they say, in 3 months, we'd like your comments on the comments. And that happened. And then they said, we'd like your comments on the comments on the comments. By then, a year's gone by. And then they called for oral testimony. And more time went by. And then lawsuits get filed, and more time goes by. So this political process playing out alongside the development was very easy to exploit. In general, the monopoly was a divisive issue throughout. We had an economic argument that said base stations are really expensive, and if you don't have a lot of channels on a base station, you don't have a lot of customers in that cell, and your system becomes extremely expensive. So we need all the channels in order to make the system cost really nice and low, like $30. If you only give us half the channels, the customer, the poor customer, will have to pay $50 a month. If you only gave us a quarter of the channels, the customer would pay over $80 a month. So we have this monopoly argument. Monopoly is going to be better for the customer. On the other hand, Motorola and the Department of Justice have a philosophical issue. Monopoly is not good. We have to get rid of monopoly. Doesn't matter if it seems to be cheaper for people. So this is the argument that's going to go on for years. In parallel with this political debate, we're designing a system. And this system was a joy to work on, because it had so many questions, and they were all interesting questions, like this issue of you had to take propagation tests and run computer simulations to decide how far apart the cells have to be. And how are you going to, you have to know where the car is to know what cell to put the car in, so that's locating. And then the car moves into a new cell, and that's handoff. And to do all that, you need signaling. And how many channels do you need to make the cost correct? And how good does the audio have to be? Because the better you want the audio to be, the less interference you want, so you have to put the channels further apart, so you have fewer channels on every cell. Everything connects, and it's all fascinating work of many kinds. We had a ball working on this for many years. And the way I remember this whole period of time was the joy of working on these interesting problems with smart people, and then the delays that would suddenly hit you. Like, we proposed a major customer trial in Chicago, and it was the obvious thing for us to do. It was the right thing to do. Motorola objects to it. The FCC denies our application. We submit the application again, and a year later it's approved, the same application. So we watch a year go by. And now we create this cellular system in Chicago. This is a real trial. We had 1,000 paying customers in Chicago on a cellular system in 1978. They were still in that trial system in 1983 when the system was cut into commercial use finally. 5 years of a trial. The trial was delayed for a year, and then it lasted for 5 years as a trial. So this is a frustrating world. What finally happened was there were compromises made, and we finally got a ruling out of the FCC, and then there was a final surprise. The first issue was recognizing that it wasn't going to be a monopoly. Now, I was personally passionately committed to it being a monopoly because I could see it was going to be cheaper and better, and we were going to do a great job. I mean, our argument to the FCC was we have the technology to build this system. AT&T has the money to install it in a nationwide network at a very fast rate. The public will benefit. I got a call one day to go and see a friend of mine in headquarters in Manhattan. He was the federal regulatory guy, and he said, Dick, can you make the system work with half the channels? And I went into my rant, no, that's a stupid thing to do. It'll make it more expensive. The customer's not better. And he said, no, you don't. That's not the point. We are not going to get a monopoly. There is no appetite in the FCC to go up against the Department of Justice and give AT&T another monopoly when they've been trying to break up the one we already have. You're not going to get all the channels. The question is, can you live on half or should we just quit? And I said, oh, in that case, let's take half. And that really was a log. I didn't realize how much this was holding us up. He went to Washington and he told them, we could get half. Not a quarter, though. Quarter is too much, but half. And it broke through. That's what they wanted to hear, and that's how it ended up. Also, there was an EIA committee that I served on that the FCC wanted nationwide compatibility. And we got that committee to agree to a set of rules for all cellular systems in the US. And that made the FCC happy. And then the other thing was that cellular technology was a US technology. We led the world in that, and all other countries came to the US to learn about cellular systems, but suddenly they're putting cellular systems into service, and we don't have one in service. And so that was an emotional thing for the country. All that finally came together, and the FCC said, yes, 2 systems, 2 competitive systems in every market, and you can have 1,000 channels total, and go for it. So finally, we had everything we really wanted, and we were setting out. The AT&T created a subsidiary called the AMPS Corporation to actually plan 100 systems, and we're out there talking to the telephone companies about how to do this. And then just months later, big headline, AT&T agrees to break up the monopoly. So on the verge of after all these years of fighting for this, the whole world changes out from under our feet. So how did all this play out? For the telephone companies, it wasn't that big a change. I mean, they would have operated the systems anyway. They were still going to operate the systems. Only now they can buy equipment from whoever they want. They didn't have Bell Labs advising them, which I think cost them. But basically, they were happy. The cellular development organizations, which were Radios in Whippany, New Jersey, and the Switch in near Chicago, they went on being Bell Labs. Only now they're Bell Labs in a competitive world. They don't have a lock on selling stuff through Western Electric to all of our telephone companies. They're competing with everyone else. So I must tell you that for developers and manufacturers, life is easier when you're in a monopoly. So they're still around, they're still doing stuff, but life is harder than it used to be. The systems engineers, which was my department in Homedale, we had always been funded by the telephone companies, and we didn't have jobs anymore. So we could have gotten into development, I suppose, but most of the people that were in my department working on that first system sort of evaporated. Well, you didn't evaporate. You still seem substantial. Into a variety of new jobs. And it was a very sad thing because we had seen ourselves as planning the whole future of new generations of cellular systems, and that was not to be. But a luncheon tradition was born that still goes on today, and you're probably wondering why I want to tell you about that, but here's some of us a couple of years ago. We meet for lunch 3-4 times a year, and we're getting old. But you think about that. We have been meeting for lunch for 35 years. We haven't worked together in all that time, and we're still meeting for lunch. And so you might ask, what would we be talking about? And I give you one clue. We don't talk about how many billions of people have cell phones. We don't even talk about what we worked on in those years. So before I answer the question, I want to kind of ask you to think about something. I ask my students this each semester. Think about when you finish your career, what sort of thing would you like to be able to say about what you did? And that's a very personal question. So you get certain, I don't have time to poll you here, but some kinds of answers. You could win a Nobel Prize. You could start a successful company. You could rise through your own, to the company that hires you to be a vice president, a president of the company. You could become rich. There's all kinds of things that you might think you'd like to accomplish in your time there. Do you notice anything about all those options? Is there something missing? Can somebody think of a? Every single one of those things is a retrospective view of what happened in your career. You don't know until the end how those things happened. So now let me get back to the question, what is it we talk about when we meet for lunch? We had a great time. Working on this, the work was wonderful, yes, but we had fun all the time. We really, right? And that's an irreplaceable thing. So let me ask the question in a different way. If you could say your career is maybe, what, 10,000 days? If you could say, I loved going to work every day for 40 years, what's that worth? And if you loved going to work every day for 40 years, and then at the end, you didn't get the Nobel Prize, or you're not rich, or the system that you created didn't turn out to be a big success, well, what are you going to say now? Oh, I had a ball for 40 years, but I'm a failure. So I think when you're young, it's very natural to have some sort of a grand objective, something important that you'd like to achieve. But don't lose sight of the fact that how you feel every day is an awful lot of days. Okay, so Act 2, the system got built. Act 3, I say cellular explores its limits. The growth, the unbelievable growth that none of us expected. When I was asked how big cellular was going to be in, by the end of the century, the year 2000, I said, yeah, we're hoping for a couple of million people. We had 60 million. None of us expected that. So what happened in cellular between 1983 and let's say 2007, 25 years? Yeah. That 25-year period was amazing. But I'm just picking out a couple of things that I think were particularly important. I'm not running late, am I? I don't. No, okay. The car phone became a pocket phone. That was really important. And it was important in an interesting way. A phone always was in a place. It was in your kitchen, it was in your living room, it was in your office. A car phone is also in a place. You're calling a car and speaking to whoever happens to be in it. Now, I have a single owner, but it is a phone in a place. A phone in a pocket becomes a personal phone. So when that happened in the 1990s, the nature of the cellular became personal communications. And I think, the fact now that you call a number, you expect to talk to a particular person, that's the result of the pocket phone. Another thing that happened was that the FCC, who had given away 1,000 channels to start all this going, came up with some more channels around 1992 at 2 gigahertz. And this time, though, they said, we gave away all that, so why don't we sell it? And so they started auctioning channels. And the channels, cellular had the public attention. Entrepreneurs were looking at cellular thinking, wow, that's really growing. That's a big business. A lot of people wanted to be in the cellular business. So the bidding was brisk and the channels cost a lot of money. And I noticed something, if you want to think about starting a company, see what happened out of those auctions in 1992, in most places, where you used to have 2 competing systems in a city, suddenly you had 4. So they created more competition by adding another frequency band of channels. But I think the buyers of that frequency maybe didn't think about the economics well enough. Because here they were, 10 years after the people they were going to now compete with, who got their spectrum for free and already had millions of customers, and they're going to come in and pay for spectrum and compete. And so what you might notice in most places, and this is in the US and in Europe, in places where this happened, the 3rd and 4th system have never done as well as the first 2 systems. So it went through a bunch of strange combinations and all that, but right now, all of those first systems come down to AT&T and Verizon. And what are the other 2? T-Mobile, Sprint. They've never been able, they've struggled for years to try to offer meaningful competition. And it's not easy when you start late and you're forced to pay for something that your competitors didn't have to pay for. So that's another thing you can notice in the world when you're trying to create a system. And then something else interesting happened. Now, AT&T, when they were broken up, they became a competitive company in a lot of businesses, most of which went badly. And they said now they wanted to get into cellular. So to compete with their own telephone companies, their old telephone companies. So they bought McCaw Cellular. An entrepreneur had created a budding nationwide cellular network. AT&T bought it for, let's say, $16 billion. And now AT&T is in the cellular business like they always wanted to be. I mention that because it matters in just a moment. The next thing that happened was what we call 2G. So if our system, the first system, that was 1G, the first generation. 2G was digital. 1G was an analog radio. 2G was digital voice. The thing that made that important was that the science of voice compression had really taken hold. And once it was a digital voice, they were able to compress it to 1/3 of the bits they started with. So what that meant was that a channel that used to be an analog channel for one conversation became a compressed digital channel with 3 conversations on it. So suddenly, there were going to be 3 times as many calls in a system by just replacing the radios. So that was a very big deal. I, as the old monopoly head, thinking about how great monopoly is, I said, wow, these companies are going to make money hand over fist. Think about it. The cells are the expensive things to put in. Now they can just change the radios and triple the number of customers without putting in any of these expensive cells. They're going to make money hand over fist. That was my monopoly mind working. But you see, this wasn't a monopoly. This was a competitive world. And that old monopoly, AT&T, decided, we want to grow by stealing customers away from those other guys. So we're going to make a great deal. We have this nationwide network, so we're going to make a nationwide calling plan. You can have 60 minutes for whatever. And that was selling minutes a lot cheaper than the systems had been selling them before. So, what happens? If you look out 10 years, you don't have 3 times as many customers on a cell, on a base station. You have customers talking 6 times as much. AT&T's maneuver caused everyone to start talking more, so all of the capacity gain and more from digital voice compression went to the customers. And I say that because it was at that moment that I said, oh, so there is something about competition. All those years I was saying it would be cheaper for the customer if it was a monopoly, there's another side to that story. And so what we see happening here is how competition in the cellular business drove all the benefits of a new technology to the customers. So at the close of Act 3, what we have in cellular is a wildly successful business. Almost everyone in the country has a cell phone. With these new packages, people are talking all they want to. Minutes have not been going up at the end of this period. People talked a lot more, but then they talked enough. They had about 8,000 minutes a year per customer. That's all they wanted. So we have a system here that's doing its job, but now this miracle of technology has become an old hat sort of thing. And people are starting to pay less for it. So the revenues have fallen from about $50 a month to about $40 a month. But something cool happened that made up the difference. A new service appeared called texting, which is virtually free for the operator. This amount of capacity you need to send a few bytes to somebody else, it's nothing. It's far, far less than a minute of talking. And yet they were charging as much for a text message as for a minute of talking. So they had this wonderfully powerful and profitable new service that brought the total revenues back up to $50 again. And life was good. I mean, these systems were a success story. And then they connected to the internet. So, as you know, the whole nature of a cell phone changed. Talking became a secondary reason to have a cell phone. Your primary reason was all of those things you could do with that phone. But the amount of data was huge. And I remember putting it this way. If you looked at the internet, the internet was a fiber-based system. And in the period of time we've been talking about, the fiber used in the internet, the capacity of a fiber had increased by about 1 million times from the 70s to the first decade of this century. 1,000,000 times. And how much do you think a radio channel had increased in its digital capacity in that same period of time, in its information capacity? Nothing. Radio did not increase in the time that the fiber went up 1,000,000-fold. So what this gave you was customers of the internet who believed that information is infinite and free. I mean, basically, you could do anything you wanted on the internet. But now you had a radio system, the cellular system, attempting to access that internet for you. So you were running the infinite internet through a bottleneck called cellular. The cellular system was not particularly good at downloading a lot of data. It was an expensive way to download data. So this problem, they were very bullish about 3G technology and MIMO antennas, and they lost sight of the fact that the internet was hugely more demanding than voice had been. So, for example, by my calculation, in the 10 years of smartphones, they have had to provide an increase of about 50-fold in capacity. And some of that was free. It was helpful that most of the data off the internet is download, it's not two-way like voice, so that helped. It helps that people who use smartphones use them day and night. I mean, you wouldn't call someone at 3 in the morning, but there's a lot of people on their smartphones at 3 in the morning. So the system was loaded more efficiently. So yes, it's one-way traffic, it's more efficient loading, but they added cells, which cost $1 million a piece, and they bought a load of spectrum. And by putting all that stuff together, they were barely able to provide that miraculous increase in capacity. They spent, in total, the cellular operators, $250 billion in the last 10 years, mostly, I think, on spectrum, to give that wonderful service. And if you look at what they were, if you looked at them, if the voice was looked at as selling bytes to people, a megabyte of voice in 2007 was costing about 60 cents. 60 cents a megabyte. Now they're getting 2 cents a megabyte. And they spent $250 billion to achieve that, and the revenues people are paying them have dropped from $50 a month to $42 a month. So this is a serious problem, which you may not have fully appreciated, but meeting the demands of the internet through a cellular system is causing real stress to the telephone companies. And that's something that has to be worked on. So what does that bring us to? The talk of the day is 5G. What is 5G? I don't know. 5G, at least in part, is millimeter wave frequencies. Why? Because there's a huge amount of frequencies, of spectrum at frequencies like 28 gigahertz. And it would be pretty cheap to buy it. So you'd think, well, you'd want to go there and buy that spectrum. But it's not easy spectrum to use. It tends to have a very short range. It tends to not penetrate buildings well. It tends to scatter with rain and with leaves on trees. So this is a difficult moment, and there's a lot of talk about 3G and what it is. I'm not sure the operators have figured out how to use it. So they have this very demanding moment. The load keeps growing. The service is becoming less profitable. It's very hard to figure out. There is in my view, what cellular has to have to satisfy the internet customer has to be a somewhat different architecture. And the way I would model that is, you have a device in your room, costs about $50, and it has the capacity of $1 million cell. That thing called Wi-Fi should be an image that you say, I have to be using that somehow in the system. I'm not talking about hotspots here. I'm talking about creating something within the system that is points of capacity that are not continuous like cells, but that you put in good places, and when a person passes through those places, you think of a toll booth, think of spots along a highway, think of a bus stop. There are places you can put these things that hopefully could make them very heavy download options for almost no money. So somehow, I think that's an ideal marriage of things that look like Wi-Fi, which I call info stations. Isolated, high data capacity points scattered within the system, plus the system itself, which gives you the coverage everywhere else. That's just my idea. What I'm saying is some real architectural thinking is going to have to get done. And I would say that what cellular looks like 10 years from now might be rather different from the way it looks today. So that's my story of the birth and growth of a technology in a messy world. Have any easy questions? No.
I want to get a chance to use the cube.
He really wants to use the cube. He is going to be hurt.
Charlie, throw it after. Somebody in the back. So you can throw it.
All right. Let me ask a question. You mentioned the two systems, AT&T and Verizon. They have very different radio technologies or very different digital technologies. AT&T, T-Mobile are on one team, Verizon and Sprint are on the other team. How did these two teams arise? And how did we get two different incompatible radio technologies?
Well, are you talking 2G, 3G and 4G?
I guess 3G.
I mean, there isn't a whole lot of difference in terms of capacity between what AT&T is doing and what Verizon is doing. There's a difference in download speed, but there's a very big difference between download speed and capacity. So in other words, if I could use my spectrum to give you something faster, but I have to use more spectrum to do it, that's not a real improvement in the downloading of this. I think that neither of their technologies is an answer to the problem. Yes, I think Verizon's technology is probably it's a little newer, but neither of them is solving the problem. I think that's the case, and it's probably not a great thing when these big competing companies start creating different technologies that are not compatible. They seem to, even going into 5G, they have the potential to make it even less compatible. So that's a problem for the customer. But I think that neither of those are coming anywhere near to where they need to be profitable in the future. They're just not enough capacity at too high a price. They have to do better. Oh, there's a hand.
So if the system you're proposing, it sounds similar to what we have here with EDU Room and throughout all colleges, to have essentially Wi-Fi stations everywhere. How would that replace, or would it not, in-home Wi-Fi and impact local networking that requires,
Okay.
a local network?
Actually, if I gave that impression, then I didn't do a sufficiently good job in saying what I meant. What happened when the cellular companies couldn't seem to meet the demand, they started putting in some Wi-Fi scattered around, which they can't charge for. They just sort of saying to the customer, it's like a flag of surrender. Like, we can't meet your needs, so go find the Wi-Fi. And so they put in some hotspots of their own, but actually most all of you are using Wi-Fi probably for 3/4 of your downloads, aren't you? I mean, my students are. So Wi-Fi is being used extensively by cellular people. I'm not talking about that. That's already happening. That's fine. What I'm saying is that there ought to be something that looks like that, the kind of a radio that sends a very high data rate over a short distance, and it's not creating a continuous network. It's just here and there and somewhere else. So in fact, it's efficient because when you spread these things out, you don't have interference. So you can put all of the spectrum in every one of them. And what I think they should be doing is buying spectrum. This is not real Wi-Fi, because this has to be inside the system. So I'm picturing the Wi-Fi-like terminals on their own spectrum, and an experience for the user, which is you don't know where you're getting it from. You've asked for some information, it gets to you. You don't know that there's, whether it's what I call an info station or whether it's a cell site. Whatever is most efficient for the operator, if they have a chance to give you a download through one of these cheap terminals because they know you are there, that's their business. And it's not like Wi-Fi in another sense. If you get half of your file, there's no reason why they can't give you the other half through the other system. So if you're passing through one of these little coverage areas, they're only a few hundred feet, and you get most of your file but not all of it, they can give you the rest of the file through the continuous system, or through another one of these spots. So what I'm saying is that if they had done a better job of system design 10 years ago, they would have said, we need to put a lot of these places in on our own buck, paying for the spectrum, and finding a way to use those as much as possible. And that's why it matters where we put them. That's why you want to put them in a toll booth, or why you want to put them on a street corner in the city, or why you want to put them on a bus stop, or why you want to put them on the bus. For example, what if a lot of the load on your system is things like movies and music and YouTube and whatever you guys are downloading these days? If that's a big load, and it's, so much of what you talk about now is viral. Viral means a lot of people are downloading the same thing. That kind of stuff can be cached in one of these info stations. It doesn't even need a connection to the network. So it's almost free. You could put up one of these things for $1,000 and download movies to people. You could keep it just for the big files that a lot of people want. Or you could connect it to the system. What I'm trying to say is the image of Wi-Fi should have given the operators an idea. What do we do with something that looks like that to take the load off ourselves? And if they used their own spectrum, then they could have charged for that. I mean, hotspots, they basically just giving it away. Does that answer your question?
Yeah.
Very good. I'm impressed.
That was good throw. I think you emphasized that you love your work every day. So this might be a little bit more of a personal question, but would you trade love for work and the enjoyment you had every day for the continuation and the momentum for Bell Labs?
I'm not sure what your question is. I'm sorry, but if Bell Labs continued, I would have had the continuation of that joy. So
Right.
I mean,
But if you had the choice and the option where work would get a little bit more difficult, or you'd be placed in different situations.
like what? You mean would I have liked competition, or I'm not sure what you're asking me.
Well, what I'm asking is that if you could trade just the aspect of just the continuation and continuing working with Bell Labs for your enjoyment that you had every day.
I didn't trade. I had it. I worked on this system up until divestiture when the monopoly broke up, and then I stayed in Bell Labs. I went and worked on cordless telephones, and that was a wicked competitive business. And we had to cut the cost of our phones, and we set up factories in Singapore and Hong Kong, and I was traveling there, and we made a profitable business in cordless phones. It didn't work out in the long term, but we had a great business going. I loved that. That was fun too. So I mean, I don't feel like the monopoly was necessary to loving the work. I think I once had to describe what I thought was the ideal life for an engineer. And my definition was working with brilliant and creative people on problems that are difficult and interesting, and having a dream that what you're doing is going to change the world. And if you've got that, you ought to be excited when you go to work. And what I'm saying is, all the time you're doing that, you don't know how it's going to work out. So if you're happy and you don't know, then how can you say retrospectively if it works out? You know, you can't take away being happy. And you know, to me, the comparison of some, you know, late life thing, say, oh, I developed that system and look how important it is, or I won a prize, or I even became rich. To me, there's nothing. How can you do better than loving your work for years? What else? What could be better than that? And so, that could sound a little Pollyanna-ic, whatever that word is, but I think it's perfectly logical. What could be better than loving what you do? I mean, people who, there's a whole, two ways of looking at life, I think, that are fundamental. I call them the means people and the ends people. And there's an old expression, does the means justify the end? And what that really talks about is what you do for where you want to end up. So in other words, should I live my life doing whatever I need to do because I want to end up there? Or should I live my life doing what feels good and it ends up where it ends up? And I think that there's no right answer. You know, a person is a person. You feel the way you feel. But I feel like people I know who do that second thing just seem more relaxed and happy about their lives. And the things, when people want things way in the future, I think they're often disappointed when they get them. So why would anyone trade loving today for something that might be true about 40 years from now? That's just the way I feel about it. And believe me, I am not moralistically telling you how you ought to be. In fact, when you're young, you're much more likely to think that you want to accomplish great things. I'm simply pointing out a possibly different way of looking at the world. Got two. Throw it in between and let them fight.
Okay. So one of the most controversial topics recently has been net neutrality, and eliminating net neutrality might open up more lanes of competition between cellular companies. But also one of the big points is that keeping net neutrality is better for the customer because it allows us to not be throttled. So as someone who's been in this field for a long time, what do you think better benefits the customer?
I think we're now wandering into an area where my view is no better than anyone's. I mostly feel discouraged these days about what happens with what businesses are willing to do with my data, or I've begun to assume that they'll do the worst thing, and therefore I like net neutrality. I just, I don't trust companies anymore. Is that? Well, that's just me. I'm sure they're really wonderful. You don't put this on the web, do you? The questions too? Oh, God.
Hi, so I have a question. So in terms of downloading, do you consider the peer-to-peer computer networking is closer to what you are talking about today?
I don't think so. Describe to me what you mean by peer-to-peer.
So it's like when there are multiple people downloading the same thing, so each individual is acting like not just a receiver, but also a resourcer to like the other people who are downloading the same thing.
Yeah. At WINLAB, years ago, we worked on this a lot. The question was, each person can be a base station for somebody else. You can have, ad hoc networks forming to do things. And those are in the university, they're fun to work on. I don't know what's practical. The ad hoc networks, they led to all kinds of fairly difficult questions like, would I use my battery to give you something? And if I did, I would have to have a benefit coming out of that. So how do I get paid? And then people were inventing currencies. And so it all became a little far-fetched. In other words, there wasn't an easy path to getting everybody cooperating in some sort of a network. I don't say it couldn't be done, but we eventually just got tired. It seemed a little bit of, a little socialistic or odd. We didn't know how to make it a real operating system. It was just a cute idea. But that doesn't say that you couldn't.
So for this thing, I just noticed it was used in China, but it's illegal here in the USA. So I just want to ask this question.
What's legal in China but not in the US?
It's this peer-to-peer.
It's not legal here?
I guess so, because there are so many like downloader apps in China, so we can use that. Like when you're downloading something, it will just show a P2P sign at the end of the file you're downloading, and it's much faster. Then there's not.
So it's working. You're saying it's working in China?
I think so, yeah.
Oh, that's cool. You have to understand, by the way, that I'm kind of out of this business. I sort of follow it, but I don't have the kind of insider knowledge that I once had.
One more question, then we have the reception.
Okay. My question was pertaining to the person who hired you. Was there really no insight into how he found that new radio system that he wanted you to work on? And was that it? When he died, did no one look into where did he get this idea from, or who started that?
Okay, this was a difficult and complicated situation. My guess is he's a department head now, and I'm a 22-year-old engineer. So What his motivations are, I can only guess at. The fact that he put us on this thing, which turned out to be what the FCC asked for a couple of years later, makes me suspicious. Now, he also was a department head in an area that didn't really have a reason to work on a cellular system. It was the station equipment, it was called. He worked on telephones and things like that. So when the FCC acted, he, I think, wanted to become important by having this information, but I think he also got his knuckles rapped for, why are you working on this, spending the company's money? That ought to be in systems engineering. So there's all kinds of this stuff going on. And we give him our memo in late '66, and it's still in his inbox in the beginning of '68. And we keep saying, why aren't we publishing? And we're getting into serious arguments with him. So there's stuff going on there that I can only guess at motivation for. And what I'm saying is, if he was hoping for something like that to happen, it didn't work out because he died. And even if he hadn't died, I believe that work was not going to be under him. It was going somewhere else. And Phil Porter and I went to somewhere else to continue that work. So a lot of just thoughts about what might have happened. I'm not really sure about any of what his motivations may have been.
Okay, Dick will be in the reception, and you can talk to him and ask questions.
Okay.